Every monsoon, the same question returns across parts of South Bengal. Can we live safely with our rivers? For communities around Ghatal and the surrounding floodplain, flooding has been part of life for generations. Heavy rainfall, rising rivers, overflowing channels, agricultural losses, disruption of daily life. But behind every flood event lies a deeper engineering challenge. Because floods are not created by one river, one rainfall event, or one location. They are the result of an entire river system responding together, and therefore the solution must also be based on understanding the complete system. This is the engineering challenge behind the Ghatal Master Plan. To understand the solution, we first need to understand the geography. The Ghatal region is connected with a network of rivers, including the Dwarakeswar and Shilabati rivers, which ultimately contribute to the Rupnarayan river system. Further downstream, the Rupnarayan connects with the Hooghly River before reaching the Bay of Bengal. This means the movement of water is not restricted by administrative boundaries. A river does not understand districts or political borders. It follows the natural laws of hydrology. Rainfall in upstream areas, river discharge, channel capacity, downstream conditions, all these factors combine to determine flood behavior. Therefore, flood management requires a basin-level approach. The flood challenge of Ghatal comes from a combination of natural and hydraulic conditions. First is rainfall intensity. During extreme monsoon events, large quantities of water enter the river system within a short period. Second is river carrying capacity. Every river has a limit to how much water it can safely transport. When incoming flow exceeds its capacity, water begins to spread into surrounding floodplains. Third is sedimentation. Over years, rivers naturally carry and deposit sediment. This can influence channel depth and flow movement. Fourth is the low-lying nature of the landscape. Floodplains are naturally connected with rivers. They store water during extreme events. The engineering challenge is to reduce harmful flood impacts while respecting the natural behavior of the river. A large flood management project cannot depend on a single structure. A sustainable solution requires multiple engineering measures working together. The objective is to improve the overall performance of the river system. This may involve improvement of river channels, strengthening and reconstruction of flood protection structures, improving drainage connectivity, managing hydraulic control points, enhancing monitoring and forecasting systems. The approach is not simply to block water, it is to manage the movement of water more intelligently, because successful flood management is about controlling risk, not controlling nature. Before building any flood management structure, engineers must understand how water moves. This process is called hydrological and hydraulic analysis. Engineers study how much rainfall occurs, how quickly does runoff reach rivers, when does peak discharge arrive, how does water move through channels, where are the critical pressure points. Using rainfall data, river flow measurements, and computer-based modeling, engineers can simulate possible flood scenarios. This allows planners to test different solutions before implementation. Modern flood engineering begins with prediction, not reaction. For communities living near rivers, embankments remain an important line of defense. But an embankment is much more than a raised earth structure. It requires proper design, slope stability, material strength, regular inspection, maintenance planning. Weak points in flood protection systems can become critical during extreme events. Therefore, long-term flood safety depends not only on construction, but also on continuous management. A strong structure requires a strong maintenance system. Another important aspect of river management is controlling hydraulic behavior. Structures such as weirs can influence water levels and flow conditions. They can help manage certain hydraulic requirements depending on design objectives. However, every structure changes the behavior of a river. Therefore, engineers must consider upstream effects, downstream impacts, sediment movement, seasonal variations, environmental conditions. The right engineering solution is not one that fights the river. It is one that works with the river system. Flood management does not end when river levels decrease. A major challenge after flooding is the slow removal of trapped water. Therefore, drainage systems are an important part of flood resilience. Improved drainage connectivity, efficient water pathways, pumping where necessary, removal of local bottlenecks. These measures help reduce the duration of waterlogging and support faster recovery. The future of flood management will increasingly depend on information, real-time river monitoring, rainfall measurement, satellite observation, digital modeling, early warning systems. Technology can help authorities understand changing conditions before a flood reaches its peak. The future approach is moving from emergency response to predictive management. The lessons from earlier episodes remain important. Dams, rivers, drainage systems, wetlands, floodplains, all are connected parts of one water system. The strongest solutions combine engineering knowledge with natural processes. Because nature has its own way of managing water, good engineering works by understanding that balance. The Ghatal Master Plan represents a larger vision, not simply a flood control project, but an opportunity to create a more resilient relationship between people and rivers. The challenge is complex, but with scientific planning, engineering innovation, proper maintenance, and long-term monitoring, flood risk can be reduced. Because the goal is not to stop the river. The goal is to create a safer future alongside it. Engineering Earth's Balance, Flowline Chronicles.